Hello everyone, welcome back to Zeey. In this video we will try to see what James Webb Space Telescope recently found on exoplanet K2-18B. Subscribe to our channel and ring the bell to receive our daily videos. One question before the launch of the James Webb Space Telescope was what it could achieve in the search for life in the universe. The extended delay in launching the telescope allowed for many years of thought and speculation about what it may be capable of. It wasn't exactly designed for that. Its primary objective is to monitor infrared light and assist characterize the universe's oldest stars and galaxies, but as a huge aperture space telescope, astrobiology and exoplanet investigations were also on the table. One feature that distinguishes it is its ability to characterize exoplanet atmospheres within certain constraints, but with a much broader capability than Hubble. But there was always the possibility that in its observations it might find some kinds of signatures suggesting a biosphere on an exoplanet, particularly in regards to already known exoplanets with interesting attributes, such as the TRAPPIST-1 system. This was supposed to expand our understanding of what planetary atmospheres would be like by observing when exoplanets transit their stars, and we can see how the planet's atmosphere modifies the light. Given an aside, it was always possible that JWST may discover something surprising, given we know so little about atmospheres outside of our solar system or even a sign of life. But what's happening today, at least possibly, exceeds those expectations. Not distant from Earth, a weird exoplanet exists that will not only considerably enhance our understanding of exoplanets in general, but may also represent an alien ecology. The planet in question was already known. It's an extremely enormous super-Earth, also known as a little Neptune, despite the fact that it's probably nothing like our icy giant Neptune, 8.6 times more massive than our planet, and 2.6 times the circumference of Earth. This is a very high-gravity planet, hence it is not optimal for life. However, it may be a very unusual form of exoplanet class that allows for it, which is extremely different from our own very special type of exoplanet. This exoplanet, known as K2-18B, is located approximately 124 light-years from Earth in the constellation Leo and orbits a red dwarf. This is in the vicinity. When the light left that star, it was only the turn of the 19th and 20th centuries, barely inside living memory. Interestingly, this exoplanet was identified by the Kepler spacecraft, which also discovered KIC 846-2852 or Tabby's star, but as this exoplanet has been investigated, some very interesting thoughts about this star system have been appearing in the scientific community even before the news from JWST. Here's everything we know thus far about the host. The red dwarf K2-18 is a type M3V very cool star, much smaller and cooler than the Sun, having a radius roughly 45% that of the Sun. As astrobiology enthusiasts are aware, red dwarfs have been the subject of intense debate regarding habitability over the years. They may be suitable for life if certain hypotheses are correct, or they may not be due to their planets being tidally locked in the habitable zone, as well as flare activity from the star itself, and so on. So we don't know how good or awful red dwarfs are, but they are the most common type of star in the universe. This is complicated by the fact that certain red dwarfs are more active than others. There is a lot of diversity there. We also don't know how they flare. Current research suggests that they might not flare around their equators, which means that any planet would be secure. In this case, K2-18 is relatively active, but with an ambiguous star spot profile, which can make researching these systems difficult, as well as lead to false detections. In this system, there are two known planets, the exoplanet in question and another, K2-18c, and the two may be tidally interacting with each other, which could be important as the story unfolds. Flaring and star spots may confound observations of these worlds, so the first word of warning is that the readings can be deceiving, and when you look again, you may not see the same thing. However, the study in this case made two observations, thus it is not only reliant on one sampling. Now for the interesting planets. As previously stated, K2-18B has a mass greater than 8.6 times that of Earth. It circles relatively near to the star, completing its year in just 33 days because it is in the habitable zone of a red dwarf. This planet is most likely tidally locked, though this is not certain. The planet's density appears to be halfway between Neptune and Earth, implying that it can keep hydrogen better than a planet like Earth, but not fully. It will still lose it. It would be quite different from Neptune if it was rocky and terrestrial, but if it wasn't, it might be more like Neptune. We don't know yet, but all signals point to a bumpy road. There's also the option that it's a pure water planet with a thin atmosphere, but it was never likely and is now off the table. This system is about 2.4 billion years younger than the solar system, with a significant uncertainty of several hundred million years. This planet, on the other hand, is well within the star's habitable zone and, under the right conditions, could be hosting liquid water. However, if an ocean exists, it is most likely a high-pressure layer of forced ice over a rocky core, which could create all kinds of scenarios about how this planet could be convecting heat to its dark side if it is tidally locked. Because of limitations in what we know, it's difficult to say what the conditions of this exoplanet are. It could be a water world with a thick hydrogen envelope that protects it from the red dwarf, or it could be something else entirely. It's balancing on numerous tightropes and might go either way. Interestingly, if this exoplanet had been a little smaller, we would have been deeper into potential biosphere region. But we do know there is water vapor there, accounting for about 1% of the atmosphere, give or take a 0.5%. Ammonia is not present. Hydrogen can escape, albeit at a slower rate than it would on Earth, and it can also be restored if water is broken down by the red dwarf's radiation. The point is, as another word of caution, there is a lot of ambiguity here, thanks in large part to the fact that science and research into exoplanet atmospheres are still in their infancy. That nevertheless, fresh JWST data adds a dimension of strangeness to this exoplanet that could be crucial and will undoubtedly be the focus of considerable debate in the coming months. Carbon-bearing molecules have been discovered in the atmosphere, according to new observations. Methane and carbon dioxide are two examples. These are common gases in the universe and do not require the presence of life. However, their presence adds support to a long-held theory about a form of planet that might appear like this. It's called the Hycean world, and this is where things turn strange. The term Hycean is a combination of the phrases hydrogen and ocean. It has a hydrogen atmosphere and is a hot, water-covered planet. This qualifies them as habitable, they have liquid water, and it's even been suggested that they should be a frequent sort of exoplanet. None have been confirmed, however there are several contenders, most of whom are from the Kepler mission. These planets are anticipated to be up to 10 times the mass of Earth, making them larger than the type of habitable planet Earth. This is where K2-18B comes in. Because of their conditions, these worlds would have habitable zones bigger than that of Earth, if they are habitable at all. There are also proposed dark Hycean exoplanets that are tidally locked, with one side permanently dark, as K2-18B may be. However, problems about runaway greenhouse effects must be addressed with these worlds. Hydrogen atmospheres are problematic and may be too hot for a permanent ocean. However, before to this discovery, K2-18B was a possibility since it appeared to be at precisely the correct distance from its star to possibly avoid this and keep an ocean, and so be an example of a Hycean world. The absence of ammonia, as well as the abundance of water vapor, carbon dioxide, and methane, suggest that K2-18B is a Hycean world. However, even if it does have an ocean, it may be too hot to support life. These worlds could have atmospheres of hydrogen and other gases, an ocean with high mass gravity, which could result in very calm oceans, and a layer of pressure ice over a rocky core. Not much like Earth, but potentially habitable in a broader sense, with life existing under vastly different conditions than our own. With no land, this ocean is quite likely far deeper than Earth's oceans. And so the first mystery concerning this strange planetary begins. Since the story emerged, it has been suggested that carbon dioxide may be in disequilibrium in a hydrogen atmosphere, at least in this sense. Carbon dioxide disequilibrium in the atmosphere is a potential biosignature. It's not a terrific one, because carbon dioxide may be created by a variety of abiotic processes, but it does raise an eyebrow. However, consider another probable detection in the spectrum that discovered the CO2 and methane. It could have discovered the chemical dimethyl sulfide. However, this detection is not strong in this data. It is essentially a 1 sigma detection, when in astronomy, 3 sigma is required for anything relevant. This is the third reason of caution, since it requires substantial validation from other teams. However, if it is present, it has major consequences because it is also a biosignature gas. Dimethyl sulfide is produced on Earth in 2 ways, naturally and through industry. Upcoming JWST observations will either confirm or refute the initial detection, but if it is confirmed, then not only is K2-18B exhibiting 1 biosignature, but 2 separate biosignatures, both of which can be technosignatures, but you'd need a radio signal or something to get into that territory because the gases themselves are produced by biology. This planet has undoubtedly risen to the top of the list of exoplanets of interest, but it's far too early to get enthusiastic. This is not proof of a biosphere on an exoplanet, but rather a possibility. The good news is that more observations with Webb and other telescopes, including radio telescopes and SETI, are planned for the system. What it does is affirm JWST's power, and the fact that we saw a strange planet like this so early statistically points to a lot of strange exoplanets yet to be discovered. However, if this is a biosignature world discovered so early, then inhabited worlds must be quite widespread in the cosmos, and Hycean worlds may outweigh Earth's in terms of life. However, everything is locked in at higher gravity, both because of a massive gravity well and because that life is likely to be oceanic. If life in the cosmos is ubiquitous, but civilizations that can leave their planets are rare, no matter how sophisticated they are, it would be a tragic solution to the Fermi paradox. Alright guys, this video ends here. Thanks for watching. What are your thoughts? Is there anything you'd like to say? Tell us in the comments, subscribe and hit the bell so that you won't miss any information about this exoplanet when it becomes available.